Dear friends, wish you good health and good research. My talk is Application of Palaeomagnetism in Human Evolutionary History. My talk includes three parts. In part 1, I will give a brief introduction to the principle of magnetostratigraphic dating. In part 2, I will present magnetostratigraphic dating of key behavior milestones for human evolution history in Africa. And in part 3, I will present chronology of early human expansion and occupation in the Old World, that is, in Asia and Europe. The left is the Earth's magnetic field. This is magnetic minerals. This is magnetic field. The magnetic minerals can record the information of the magnetic field. For geologists' interest, the information of Earth's magnetic field can be fixed during sedimentation and compaction. Therefore, sedimentary sequences like this, the Nihewan beds, can record continuous and high-resolution variations of geomagnetic field, including geomagnetic directions and palaeointensities intensities during geologic history. This slide shows the principle of magnetostratigraphic dating. During geologic history, sometimes the Earth's magnetic field is normal, that is, consistent with today's direction. See the orange arrow and the black bar. However, sometimes the Earth's magnetic field is reversed, that is, the geomagnetic north pole and the south pole are switched. See the green arrow, and the white bar. Time series of the alternating normal and reverse periods. That is time series of the black and white bars is the geomagnetic polarity timescale, GPTS here. This is the timescale of the past 6 million years, and this one is the timescale of the past 150 million years, from late Jurassic to Quaternary. Magnetostratigraphic dating aids to correlate the recognized magnetic polarity sequence in a sedimentary section to a reference geomagnetic polarity timescale. This is a magnetic polarity sequence like this. This is the timescale. How to correlate this magnetic sequence to the timescale? The geomagnetic polarity timescale of Pliocene and Pleistocene is widely used for dating early humans. That is the timescale, including the Gilbert reverse claw, the Gauss norm claw, the Matuyama reverse claw, and the Brownies norm claw. The geomagnetic reverse boundaries, that is, from normal to reverse, or from reverse to normal, have been well calibrated by isotopic dating or orbital tuning, thus leading to precise dating of early humans. For example, in the Nihewan Basin sections, the left is the timescale. Here is the Matuyama-Brownies boundary, recorded here, MB boundary. Harmel recorded here, and Olduvai recorded here. For strata containing human fossils or stone tools, they are different from Africa to Asia. For example, in Africa, there are plentiful ash beds. The sections are pretty thick like this, usually tens of meters. Thus, the sections are suitable for both isotopic dating and magnetic stratigraphy. In Southeast Asia, here, Also, there are plentiful ashbeds for isotopic dating, but the thin sections are not good for magnetic stratigraphy. However, in China, no ashbeds available. Thus, the precise isotopic dating method doesn't work. Fortunately, Chinese sections are usually thick, like these 91 bits, and the North Peninsula sequences, sometimes more than 50 meters, even more than 100 meters. They are very good for magnetic stratigraphic dating. Let's move to part 2, magnetic stratigraphic dating of key behavior milestones for human evolution history in Africa. This slide shows some important behavior and morphological changes and hominin taxonomy. Magnetic stratigraphy, together with isotopic dating, can contribute significantly to the chronology of early human evolutionary history. For example, from here to here, from the human-ape divergence to Homo sapiens. Also here. In this part, I will present some research about magnetic stratigraphic dating of the key behavior milestones for human evolution history in Africa, including human-ape divergence, upright walking, Paleolithic technology, the appearance of Homo erectus, and meat eating. The first milestone is human-ape divergence. Our ancestor, the earliest hominid, appeared in this planet. The first evidence is Sahelanthropus. It was discovered in Chad, Central Africa. The fossils were determined to be about 7 million years by cosmogenic nuclear dating and by chronology. Its age indicates that ape and human diverged in the terminal Miocene. For this milestone, magnetic stratigraphy did not make contributions to the chronology. However, almost at the same time, in the southeast margin of the Tibetan Plateau, the southeast margin, that is, in southwest China and Southeast Asia, the ape went to extinct. So far, the youngest ape fossils are roughly 6 million years. One is in the Baoshan Basin, here, and the other in the Zhaotong Basin is here. Milestone 2 is upright walking. The earliest evidence for upright walking is legs of Orion. The fossils came from Tugen Hills, Kenya, East Africa. Magnetic stratigraphy placed the fossils here in Cron C3R. This is the magnetic polarity sequence. This is the time scale. The age is between 5.2 and 5.9 million years. Additionally, the potassium argon and argon dating results show that the fossils are roughly 5.8 million years, very close to the end of the Miocene. Milestone 3 is the making and use of stone tools. 3 types of Paleolithic technology are discussed here. The oldest one is Lomquin technology, and then the other one. It was previously believed to be the oldest. And finally, the Ashurian technology is here. This slide shows the oldest stone tools discovered in Kenya and named Lomquin technology. It was dated at 3.3 million years by magnetic stratigraphy and argon dating. This is the argon results. This is the magnetic polarity sequence. This is time scale and the correlation. The red star shows the position of the oldest stone tools, just within the mammoth reverse crown. Very precise and very less dating. The Lomquin technology is 700,000 years older than the other one technology, thus marking a new beginning to the long archaeological record. This is the oldest other one technology discovered in Ethiopia, dated at 2.5 or 2.6 million years by argon dating and magnetic stratigraphy. The triangles show the position of the other one technology. This number and this number is the argon results. And here is the Gauss-Matuyama boundary from normal to reverse. Thus, the other one technology is just above the geomagnetic polarity reversal. Thus, the edge is very close to this edge. Also very precise, very less dating. This is the earliest Acheulean technology discovered in Kenya. It was dated at 1.76 million years by magnetic stratigraphy and also argon dating. This is argon results. This is the magnetic polarity sequence. This is the time scale. Here is outline. The red star shows the position of the Acheulean technology, just above the upper boundary of the outline. So the edge is also very precise and very nice. Method 4 is the appearance of Homo. The oldest Homo fossil was discovered in Ethiopia and dated at 2.8 million years, also by argon dating and magnetic stratigraphy. Here's argon results here, here, and here. And the dots is magnetic data. Also here, the magnetic data. This is late Gauss crown. This is the position of the earliest Homo. Thus, the age is late Gauss age or late Pliocene age. So, this specimen combines primitive traits seen in early Australopithecus with derived morphology and observed in late Homo. Method 5 is the appearance of Homo erectus. The earliest fossil of Homo erectus came from South Africa. Magnetic stratigraphy shows that the fossils are located below the outline. This is the magnetic stratigraphy. Outline is here. Below, the red star is the position of the fossil. And above the Gauss-Matuyama boundary is the Gauss-Matuyama boundary. In addition, we consider the combined uranium series and ESR dating. Uranium series, ESR dating, and uranium lead dating. Combined these dating results. Age of the Homo erectus is about 2 million years old. So these cranial fossils show that Homo, Paranthropus, and Australopithecus were almost the same period at roughly 2 million years. Method 6 is meat eating. Eating meat can contribute to the increase in mental abilities and increase in the development of larger brains. The earliest evidence for meat eating came from Ethiopia. The images, the left one, show the earliest record of stone tool processing of animal tissues. First, for the age, firstly, Mammonephora shows that is Pleistocene age, and then magnetic stratigraphy shows it was early Matuyama, a little bit younger than 2.6 million years, and Agang dating 2.5 million years. So, therefore, combining the above age constraints, the earliest evidence for meat eating can be dated at 2.5 million years, the earliest Pleistocene. Here is a brief summary for this part. Human-ape divergence at about 7 million years old. Walking upright, 5.8 million years. Making and use of stone tools, 3.3 million years. Appearance of Homo, 2.8 million years. Appearance of Homo erectus, roughly 2 million years. And meat eating, 2.5 million years. As just shown, these ages have been updated. Here we move to the last part, chronology of early human expansion and occupation in the Old World, in Europe and Asia. Dependency in Georgia, West Asia, provides the earliest fossil evidence for humans outside Africa. Occupation of the Dependency site began shortly after 1.85 million years, and is documented until about 1.77 million years. These ages are based on biostratigraphy, magnetic stratigraphy, and isotopic dating of the basalt here. In the next slides, I will present chronology of key evidence for early human evolution history in the Old World, including West Asia, Europe, East Asia, and Southeast Asia. Early humans firstly expanded out of Africa at roughly 1.8 million years ago. Dependency is the first stop. Then early humans migrated from West Asia to Europe, and then to East Asia and Southeast Asia. This is the first human in Europe. It came from Sierra Atapuerca, a Spanish site. The evidence includes hominin fossil, stone tool, and meat eating. Magnetic stratigraphy here shows that the human is below the Matuyama Brunis boundary, thus older than 0.78 million years. In addition, cosmogenic nuclide dating shows that the human fossil is roughly 1.2 million years. Early humans migrate from West Asia to East Asia and Southeast Asia. The Yuan Basin in southwest China may be the first stop in eastern Old World. This slide shows magnetic stratigraphic dating of the Yuan Homo. 4 sections were studied, among which 3 sections are natural outcrops, including the left one Liujianbao section, the middle one Dapochin section, the same one, and the right one Ganta Maui section. These sections can be well correlated by sedimentary marker layers in the field. For example, the Liujianbao section and the double-chain section can be correlated by these layers. These four conglomerate layers can be traced in the field, and the double-chain section and gamma section can be correlated by this layer, the blue one, the highest PT clean layer. And according to the magnetic polarity sequence, here is the outward subcore, here is the outward subcore, the GPTS. This is the polarity of the Newton section containing the Homo erectus, the Homo incisors. So the Homo incisors is just above the outward subcore, thus a little bit younger than the upper boundary of the outward. Thus the age is determined to be 1.71 million years. Also very precise, very nice dating. Let's move to the landing area of the southern Loess Plateau, central China. Loess Plateau is here. The shaded area is the Loess Plateau. There are two human sites in the landing region. One is the Gongwang site near the Homo erectus, and the other, the Shangcheng site, yielding a lot of stone artifacts. The Gongwang Homo erectus was dated by magnetic stratigraphy and loss stratigraphic correlation. Previously, the Gongwang Homo fossil was believed to be in loess layer L15 and was dated at 1.15 million years. And in another study, see the right figure. The human fossil was believed to be in Paleozoic layers S22 to S23. Thus, the age is 1.62 million years older than this one. Thus, age of the Gongwang Homo erectus remains debated, and more work is needed. Another important human site in the landing area is the Shangcheng site. See the left one, the left figure. The artifact layers are just up distributed from Paleozoic S15 to L28, many artifact layers. Paleomagnetic dating shows that the ages range from 1.3 million years to 2.1 million years. These results may suggest earlier out of Africa, possibly by archaic Homo erectus. However, no human fossils older than 2 million years have been found outside Africa. Thus, the topic of earlier out of Africa is beyond the scope of this talk and will not be discussed here. Now we move to the Nihuan Basin in North China. The Nihuan Basin is here, is in the northeast of the Loess Plateau, northeast margin of the Loess Plateau. The Nihuan Basin is called the Eastern Outward because a lot of Paleolithic sites and fossil sites have been discovered in this basin. Xiaochongliang site is the first Paleolithic site older than 1 million years in the Nihuan Basin. This is the Xiaochongliang site. The stone tools from this site. Here is the site. The section from here to here, to here, to here. This is the section in the field. This slide shows magnetic stratigraphic dating of the Xiaochongliang human site. Two sections are studied. One is Donggo and the other Xiaochongliang. The Donggo section is the Brunnis crown, Harmiel, and Outward. However, in the Xiaochongliang section, Outward is absent. Harmiel here, Brunnis here. The Xiaochongliang stone tool layer is between the Harmiel and the Outward. Thus, the age is 1.36 million years. In 2001, this age was the earliest evidence for human presence in Northeast Asia. 3 years later, it was updated by new findings of the Majengo site. This slide shows landscape and sections of the Majengo site in the Nihuan Basin. This is a Majengo section. It's here. The site is here, also here. The stone tools from the Majengo site. The top one is the Banshan site. This is a section. This is palaeomagnetic stratigraphic dating of the Majengo Paleolithic site. Here is the paleomagnetic results. There are 4 stone tool layers. 1, 2, 3, 4 is here. It's between the hard mirror and the outer subcross. So the ages of the stone tools range from 1.32 million years to 1.36 million years. 1.66 million years. The earliest one is the earliest evidence for early human presence in high northern latitudes of Northeast Asia. This slide shows stone tools and fossil bones from the Majengo 3 site. The age is 1.66 million years, the earliest one. Here is the elephant footprint, and this one, possibly the earliest dining table in Asia. Also here, the cutting marks, the memory bones cutting marks is here and here. This may be the earliest evidence for meat eating in Eastern Asia. Now we move to the tropical Southeast Asia. Many early human fossils have been found in Java Island, Indonesia. Roughly, there are about 80 Homo erectus fossils, and roughly 50 have long fossil Paleomagnetic dating and Algonquin dating show that mainly Algonquin dating, the age is range from 1.51 million years to 1.66 million years. But this age, 1.66, is the widely accepted oldest age. However, paleomagnetic, also magnetic stratigraphy, just contributed a little to the chronology. Here is a brief summary. I only list the chronology of unambiguous earliest evidence for humans in the eastern Old World. The high northern latitude Nihuan Basin, 1.66 million years, is here. Subtropical Yama Basin is here, 1.71 million years. And the Java Island is 1.66 million years. This is the last slide for conclusion. During the early stage out of Africa, the Yama Basin is here, may be the first stop after Homo erectus arrived in East Asia, which migrated along a southern migration route. The only humans, Homo erectus, rapidly moved to high northern latitude, the Nihuan Basin, and then to the low latitude tropical area, the Java Island, Indonesia. Thank you very much for your attention.